So, you recently secured a second mission to send another rover to the moon. Can you tell us a bit about this new mission? What makes it special and different from the first mission?
Sure. So basically, first of all, we are flying with a different provider. It's also NASA CLIPS program, but it's not Astrobotic, it's Intuitive Machines. And we're flying around the same time, just a couple of months later. And obviously, they have a different lander. It's not Pellegrin lander, but it's a Nova C lander, different design. So it gives better chances of success flying on two missions, but also it allows us to bring more assets. In our case, it's rovers to the lunar surface. So the first one is the rover with legs. The second, we want to test rover with the wheels, slightly maybe larger rover with wheels that we will be testing during the first mission.
So, is the second mission only tests, or are you? Are you for the second mission too? You're going to be testing the functionalities of the rovers, correct?
Well, both of those flights are in a way tests, and they're also real flights in a way that we'll be gathering data and we will be taking pictures, and a lot of science will be done when we're on the lunar surface. So it's not only the test and the actually technology demonstration, but actually we hope that we'll be able to capture quite a lot of scientific data, and there will be a lot of data gathered from this mission that will help us to conduct future missions more successfully and obviously share that with the scientific community. So it's a technology demonstrator as well, but obviously we expect to get a substantial scientific data from different sensors that we have on board.
100%. What intrigued me the first time I stumbled upon SpaceBit is the fact that you are the first walking lunar rover. So it's literally a spider walking on the lunar surface. How come you decided to go for the second mission with the wheeled rover? What are the pros and cons for the different situations you're going to be exposed to having the spider or having, more of a traditional wheeled rover?
Absolutely. So with a spider, you can go into some remote places, rock terrain, you can climb, you can even jump in some places. With the wheeled rover, you can't really do that, so you have to drive. So surface should be more equal. You can't really go on rocks. So that's a different purpose. And that's why we're testing different technologies to see which one is suited for what environment. And obviously, first legged rover is a interesting project, and it definitely have a potential. Definitely, there is a potential for the future missions, and not only for us, but for other potentially companies in the future. They will be followers. Absolutely. I mean, someone has to be the first. It's basically it's risky, but hey, that's what we do. And then obviously the next one is actually the wheeled rover. So the wheeled rover has different functionality. It can maybe drive longer distances. It can probably go faster on certain terrain, but when it's more flat in a way. So it's different applications, and definitely excited to work on this first walking rover.
Which one can hold more battery capacity? Or actually, which one consumes more battery per hour, let's say?
Sure. Well, it's all about how you want to move and where you want to go. So if you want to go longer distances, you're probably using a car, so you have wheels, so you can get further away. But if you want to go in some difficult places and you need legs, so the consumption slightly bigger on the legged rover, just because we have more motors and they're doing more complex calculations to move those legs. But it's always a trade-off. How many batteries do you want to have inside? What capacity are you ready to leave for scientific instruments? So it's not as simple to say, well, rover is less energy consuming. because there will be different instruments, and actually on a Wild Rover we have more instrumentation included. So if you add that, then maybe it's almost the same, just because there are more instruments which will be turned on and basically consuming that energy.
In terms of size, how bigger is the wheeled rover compared to the Spider, which is almost, if I'm not mistaken, a fist, as big of a fist?
Yeah, so we're finalizing the design of our second rover. Most likely it will be twice as big, most likely, but again, that's something that we are finalizing at the moment. I'm not 100% sure. Also, looking at what instruments we want and can take on board. That's why size is important here. But yeah, we will know for sure in the next couple of months as we're finalizing our tests and proceeding towards the actually flight model.
About the instruments, is that something you can talk about?
Sure. I mean, there are plans to have instruments that you would probably put on something like that, such as cameras. Also, we want to measure temperature using our legs side of the regolith and on outside, so different spots, and see what the real temperature readings are, because well, there are many speculations what the temperature is on the lunar surface during different conditions and different positions on the moon as well. So flying, it's not as hot as an equator, for example, where it's getting more warmer in during the lunar day. Where we flying with astrobotic is relatively cool environment, up to maybe 80 degrees Celsius during the day, which is not as hot as in some other places. But that's something that we have to prove and demonstrate, and we will be doing making those measurements as well as taking pictures. But also we hope that we will be able to do some other science, such as even using some basic spectrometry to see if there is any potential for water, and maybe even using it for different applications to see what the composition of the ground. But the main goal will be maybe this water thing, so we will see. Yeah, and also radiation is important. So radiation is something that we can definitely measure, and we can see what kind of particles there are. Obviously, we will be limited in terms of instrumentation, so we can measure just some of the particles, not all of them. But it's still quite a valuable data, because all we have is almost 50 years back when it was recorded. Now, China doing very successful projects on the lunar surface, but obviously there is data from those missions which we can choose to use or not use, but it's there, which is good. But yeah, I mean, it will give us proprietary data, which we will be sharing certain degree of granularity with scientific community, which is important. I believe we should the data, and also maybe we'll put like a small radio telescope to do some other measurements, but that's TBD, weight restrictions. So we'll be seeing how we can fit certain things. And obviously there are so many things that we can take with us, but
Yeah.
it's like going on holiday where you booked economy ride, which is hand luggage. That's exactly the feeling that you have when you're flying to the moon, because you just have a very limited space, and actually you're paying a business class fare to get there as well. So
That's a good example. Have you thought of, I'm sure you've thought of it, but what about LiDAR? Because at some point you wanted to make 3D maps of lava tubes. Is it going to be done with LiDAR or camera?
So LiDAR and there's other SLAM technologies using different type of technology, such as cameras, and are one of the options that we consider. LiDAR is maybe less efficient way for us to do measurements for such a small device. A camera might be better suited with some basic measurements. So maybe there will be a combination of LiDAR plus a camera. So we need to know the depths, and then when we know the depths, have a picture, we can do other estimations from that picture. If you don't know the depths, it's kind of difficult to say if it's 10 meters or 20 meters. You can just guess from the picture. So it can be a combination of instruments, and obviously, because we will be limited on time, camera will be giving us most of information about the surroundings in a way, and then the rest will have to be calculated using that information, that visual data. But in the future, as we are more energy sufficient, definitely probably we'll be using some more advanced LiDAR technology, which is exciting. But for now, that's the way that we have to go, limited on power. But also, we're not 100% sure if we will be able to enter a lava tube during the first flight, just because it all depends if we land close enough to one of those lava tubes. If we do, then it's great. We will be able to go there and explore, maybe not too deep, so we can actually relay data back to Earth using the lander. But it's something that we will definitely attempt, and it's on our bucket list for our rover.
That's so interesting. One thing I'd love to talk about is you mentioned that the second mission you're going to be having, which is happening in Q4 of 2021 this year, right? And your first mission is Q3. Yeah. So for your first mission, you're going to be sending it on board the NASA CLPS. Eclipse, okay? And the second mission, you're going to be sending it on the SpaceX Falcon 9 rocket.
I mean, both of those missions are NASA Eclipse missions because obviously astrobotic intuitive machines are contractors for NASA Eclipse program. So both of them NASA Eclipse. But the first one is using United Launch Alliance ULA rocket, New Vulcan. The second one, which is intuitive machines, is using SpaceX Falcon 9 rocket. So that's the difference. Both of them Eclipse. First of them ULA, second one SpaceX.
Oh, interesting. Okay. So how did you change the design configuration of either your rover or the capsule, which encapsulates the rover? How did you have to do design changes for different modules?
Design changes are dramatic, I would call. Obviously, we are able to use some of our legacy systems that we have in a good way from our first rover, but because we are flying to different spots, so there is different thermal requirement both in flight and post landing, not completely but quite different thermal requirement, and also the size and what we want to put inside. So it's really a different design, not from scratch. There are some similarities, and actually we want to make it as similar as possible, but there are many differences as well. So you can't really repeat one and just do another just because there are some differences. Obviously, if you're talking about larger rovers, maybe there can be more similarities in terms of the thermal design and everything, but because we are choosing to save the weight, that's exactly what we are planning to do.
Mm-hmm. What was the decision to go with the SpaceX rocket for the second mission instead of sticking with the already existing relationship you have?
Well, we definitely want to fly with Astrobotic on their future missions. So we are not going from one to another, just choosing the best, and we believe that those two providers are the best available on the market, and that's why Astrobotic intuitive machines are our choices. And we are flying with them to the moon in 2021.
That's exciting. Okay, one thing that's interesting is that your target landing site will be the Schroeter's Valley, which is known to be flat, free of craters, and it has plenty of sunlight. For the people listening, actually, I did a bit of research before this. And imagine you're looking at the moon at the night and it's like a circle. The Schroeder's Valley is located at a 10 o'clock angle. So if you draw a clock, it's at 10 o'clock on the very edge of the moon. So why did you choose this specific location in the moon?
Well, once again, it's not our choice. It's a choice of the lander companies. Astrobotic for the first one, Locus Mortis, and as you described, the location for intuitive machines, it was described quite well. So it's exactly where we're going there. So we don't have a choice. We don't have our own lander. We have to go where they are going. And we believe those are interesting spots for exploration. The first one is interesting because there are potential lava tubes discovered in the proximity of Lacus Mortis. And the second one is also interesting for other reasons. And also, it was one of the picks for Apollo 18 flight, which never happened. So they have chosen that spot for a reason. And hopefully there will be some interesting discoveries.
Yeah, I hope so. How important is daylight for you?
Well, it's two-edged sword in a way. So daylight is definitely good, but it's also a heat. So we need it to generate energy for our battery and keep us alive, and obviously to heat us just enough to walk there. But on the same side, if it becomes too hot, that's a problem for our rover. So we need to design it in a way that the heat goes away kind of easily, and those things are happening. So it's good to have sunlight. You can't really survive with such a small technology during the lunar night, at least for now. Maybe in the
Right.
future missions we will be able to do so. But but for the first mission, that's how it is. And yeah, I mean, in some places it's just plus 130 degrees
Yeah.
centigrade, so it's quite hot. Hopefully, we're not reaching that boiling temperature on our flights.
It's funny you mentioned that sunlight is good, but too much of it is bad. It's like the perfect analogy of too much of a good thing.
And like, I mean, the reason why I'm doing those analogies is just because I haven't been on holidays for quite a bit. So that's something that is very tempting to do. So I can't do it. Like I can't even fly economy anywhere. Just So yeah.
You should fly with your
And
rover.
yeah, one day, yeah, sure. So Rover flies first, and then if everything is fine, we're definitely going.
That's funny. So, the last thing I'm going to talk about is just your first mission, which is happening pretty soon. How do you feel about that as the leader of the project? How do you personally feel about it?
Yes, well, I feel excited, and also closer to the start. I feel a lot of responsibility for a team, responsibility for shareholders, for a company, and also responsibilities for the whole UK actually, because we promised our mission to be the first UK mission to the moon, and we have to deliver. That's actually one of the reasons why we have two flights. So we really want to be a successful mission to the moon and first British company to do so. So that's very important for us.
Well, Pavlo, you have the support of the entire worldwide engineering community and personally myself. Thank you for everything you're doing.